Hello and Assalamualaikum to all panels. This is a video on our design thinking process related to smart HVAC system for indoor air quality. But first, let me introduce myself. My name is Norinara Aiman. My group members are Chi Wang, Muhammad Amir Alif bin Ismail, and Khalid Said Muhammad Kabil. In this video, I will be explaining about data collection, findings, users profile, and design statement. For data collection, we created a Google form of questionnaire that has been distributed to be answered by the public. We also conducted an interview with Mr. Atif, who is an engineer at Block E04, School of Mechanical Engineering, and does maintenance on facilities and offices at SKM. For findings, the Google form of questionnaire is answered by 27 respondents, and most of the respondents are students who spend their time at UTM or office or lab. They spend 76 to 100% of their time at the workplace, and they maintain the temperature by controlling the air conditioner. The air quality in the workplace is moderately good, though there are ventilation systems installed. They stated that the HVAC system does make the indoor air quality better in their workplace. They think that the HVAC system installed is moderately good, and they also thought that aerosol, trash bins, and smoking are the causes of bad indoor air quality. The students stated that most students stated that windows are located within their workroom, and they had complaints that is related to indoor air quality in the building, such as stuffy air or too hot temperature. They had symptoms related to work, such as itchy eye, headache, or cough. Their method for adjusting the indoor air quality is by letting natural air into the room, and they only turn on the air condition only on hot or very hot condition. And if they leave the office for 1 to 2 hours, they will turn off the air conditioner. They let their air conditioner run for 5 to 8 hours daily. These are the highlights from the interview that we have done with Mr. Atif. How do you monitor the HVAC system at SKM? Mr. Atif stated that if there is a report on any damages on the HVAC system at the faculty, the group of technicians and engineers will come to the location for repairing. Is there any ventilation system installed in SKM? Mr. Atif stated, no, there are only natural ventilation system that uses ventilation holes in places where machines that produces fume is located. The purpose of the ventilation holes is to let fresh air in. Is there any room that needs air conditioner to run constantly? If yes, what is the threshold temperature for the room? Yes, there is a laboratory that needs air conditioner to run 24 hours in order to protect the machine in the lab. There is also a server room that requires cool temperature constantly in order to avoid damages to the board. We use 2-speed unit air conditioner. The threshold temperature varies from 14 to 20 degrees Celsius. How do you manage the AC system in the lab or server room? Mr. Asif said only by controlling the room reading. If there is any report on damages, then we will go and check those rooms. Next is user's profile. We created a profile named Johan. He is a student who works mostly in a mechanical lab UTM, maintains the temperature of his working space by adjusting the air conditioner, turning the fan on, or by opening the windows manually. A ventilation system is available in the building. He runs the air conditioner in the building for 24 hours per day at 20 degrees Celsius. The pain points for Johan is that the temperature of the laboratory needs to be around 14 to 20 degrees Celsius. The HVAC system installed is moderately good, and smell from trash bins and usage of chemicals such as aerosol causes bad air quality in the lab. The indoor air in the lab is too stuffy. He often gets eye irritation, coughs, and headache while working. Johan needs a good HVAC system in the laboratory, a system that turns on or off the air conditioner based on optimum temperature, optimize the usage of AC throughout the day, a ventilation system that turns on when the indoor air is too stuffy, humid, or dry, a system that automatically brings in outdoor air when the air inside is affected by smokes, trash bins, or chemical products. Lastly is the design statement. Our group's design statement is that how can we help Johan to maintain a good air quality in the laboratory with a smart HVAC system without having to control the room temperature constantly and manually. That's all from me. Thank you.
This is Johan. Johan is an engineering student. As an engineering student, Johan spent most of his time in the laboratory. Johan enjoys doing the research in the laboratory very much. Every time, after Johan spending an hour in the laboratory, Johan felt tired and dizzy. He frequently experienced mild breathing difficulty in the laboratory after spending a long time. After doing some investigation, Johan realizes that the air ventilation in the laboratory is poor. That's why he is constantly feeling dizzy after staying a long time. Therefore, how can Johan increase the air quality in the laboratory? The problem can be solved by installing Smart HVAC system. This is the flowchart of the Smart HVAC system. This is the flowchart of the controller unit in the HVAC system. The Smart HVAC system will monitor the air quality, based on the standards set by the Department of Occupational Safety and Health. The HVAC system uses the air convection theory to ensure constant air circulation in the laboratory. This is the air ventilation. This is the prototype of the Smart HVAC system. The air quality sensors was mounted onto the ceiling wall. It detects the ppm level of the air pollutants. As the sensor senses a specific low air quality threshold, the HVAC initiates the air vents. The air vent on the left is the return vent. It draws the air to the outside of the laboratory, while the vent on the right is the supply vent. It draws the air from the outside into the laboratory. The air handling unit was connected to the supply vent. It will filter and heat up the air drawn from the outdoors according to the surrounding temperature. The temperature and humidity sensors was mounted onto the wall at each sides, on top of the air vents. They will sense the air temperature coming in and going out. The temperature going out through the return vent must 14 to 20 degrees cooler than the air coming in through the supply vent. By maintaining the temperature difference, the air convection is introduced. This ensures a constant systematic air circulation within the laboratory. The warm air is coming in, while the cool air is going out. The standard relative humidity is between 40 to 70% according to the Department of Occupational Safety and Health. When relative humidity is lower than 40%, the mist spreaders will operate. Once the air humidity reaches 55%, the mist spreaders stopped. Johan can view the air quality level through SMS or telegram notification. If the air quality sensor detects an intolerable air quality threshold that would harm the body health, an alert will be sent to Johan. The emergency signal in the laboratory will be lightened up as well. In a nutshell, Smart HVAC system protects Johan from harmful low air quality ventilation. Thanks for watching.